All right, let's take a look at the 2013 NCEA 2 Algebra exam, final end of year for year 12. This one here is question 1d, and it's basically a quadratic in disguise, in that we've got an x plus 2 and an x plus 2, and it says let a equal root x plus 2. In other words, this bit here is a. Now, this bit here then, which is not the square root of it, is essentially the square root of x plus 2 all squared, which is x plus 2, so that technically must be a squared. So let's go ahead now and turn this into the quadratic that it always was. So this here is going to be an a squared minus 3 times a minus 4 is 0. Okay, let's go ahead and factorize that. So this is this basic quadratic. We've got factors of 4 that add to negative 3. So I'm going to have an a here, an a. Signs are different. Biggest one is negative. And we're going to end up with a 4, negative 4, and a positive 1. Let's check that. A times a squared. 1 times negative 4 is negative 4, and 1 and negative 4 is negative 3. All right, so that works well. Okay, so now we have to find the value not of a, and we can solve for a quite easily. So we can say either a is equal to negative 1 or a is equal to 4. But we don't want negative 1 or 4. We want to find the value of x. So let's have a look at how that might play out. Make a bit more room here. Here we go. So instead of saying a is negative 1 or a is 4, really what we're saying is a is root x plus 2. So instead of saying a is this, we're going to say root x plus 2 is that. So let's try the first one. So we've got therefore root x plus 2 is equal to negative 1. And let's see how that plays out. So in order to find out x, I'm going to find the square root of both sides. Here we go, square root of both sides. Sorry, square of both sides. Square that side. Square that side. This is going to be x plus 2 now is equal to 1. Subtracting 2 from both sides. And where do we end up? X is going to equal negative 1. Now, I'm going to need a bit more room here, I think, so I'm going to divide the page up a bit. All right, so let's now check to see whether if we were to insert an x minus 1, x is negative 1, into the original equation, it would be true. Okay, let's see if it is. So I'm going to restate the original equation, which is x plus 2 minus 3 root x plus 2 minus 4 is 0. Does that work? So let's pop this in. So it's going to be minus 1 plus 2 minus 3 times square root of negative 1 plus 2. All minus 4 is 0. What does this come to? Well, this comes to negative 1 and 2 is going to be a 1 minus 3 times negative 1 and 2 is going to be a 1, and square root of 1 is 1, which is just, I'm just going to leave it as a 3, and then we've got a minus 4 on the end. Does that equal 0? Well, it does not equal 0. In fact, it equals about negative 6. So that is not the case. So we can put therefore negative 1 is not a solution. All right, let's try 4. So we've got a equals 4. So let's try a equals 4. So I've got, let's see how we're going to write that. Yeah, I would write something like I'll put try a equals 4. Well, we know that x plus 2, root x plus 2 is equals 4. Let's find the square root of both sides. Square that side, square this side. So this is going to be x plus 2 is equal to 16. So if I subtract 2 from both sides, x is going to equal 14. Let's see if that plays out okay. Here's the original equation. X plus 2 minus 3 root x plus 2, all minus 4 is 0. Throw a 14 in here. Well, I've got a 14 plus 2 minus 3 root 14 plus 2 minus 4 is 0. Let's see if it works. Well, 14 plus 2 is 16 minus 3 times root, well, 14 and 2 is 16 minus 4 is 0. See if that works. So I've got 16 minus, well, root 16 is 4. And 3 fours is 12, minus 12. Minus another 4 does equal 0. Tick, correct. So I put therefore 4 is a valid, I can't even spell valid this morning. Valid, that was meant to say valid. Not going well, I've only just woken up, so valid solution. Okay, so they are my two answers. So therefore, so I've underlined that one, I'll underline this one, and they would be the two solutions. So we found both solutions, but we've found only one real solution. So yeah, so I'll put and is the only real solution. Because you probably should say real because they've got a real here as well. And that would be the value of x that will make that true. Hope that makes sense.